Now that we know what a vector is, we're going to take a look at component form of a vector. So we want to know why or how to represent this on the plane and how to write it out. So you can see down here we've got a vector in standard position where the vector's initial point is at the origin. So you can see it's down here, it's 0, 0. So the component form of a vector, v, we'll call this vector v, is just its parts. So we've got v1 and v2, where v here is in standard position. So if you look at this this line segment PQ, this vector v is made up of v1 and v2, where q is x2 and y2, and p is x1 and y1. Those are their coordinates. Okay, so here again I've drawn p and q, and we've got p at x1, y1, and q at x2, y2. So yeah, we set those equal, x1, y1, x2, y2. So if p and q are equal to that, then v1 over here, as you can see, it's next to this dotted orange line, and that represents this length right here, and then v2 represents this length right here. So we're going to get v1 by taking our x2 right here minus our x1, that we want that length. And then we get v2, the other component, by taking y2 minus y1 to get that length. And that's going to give us our vector v that goes from p to q. So the magnitude of v, which is the line segment p, or the directed line segment PQ, is we mark it down here by our lines around v, and it's simply just like the Pythagorean theorem. You've got a right triangle here that we've set up, and we just take the components and square them, add them under the radical, and we get this. Alright, so here's a real quick example. It says find the component form and magnitude of the vector PQ, where p is -3, 4, and q is -5, 2. So got it on our graph over here. We've got p at -3, 4, and q is at -5, 2. So p, we're going to give the coordinates x1 and y1, and q we're going to give the coordinates x2 and y2. So we want to know the component form. We're going to take v is equal to, I should probably write this here. Remember we had v1 first and v2. So v1 is equal to x2 minus x1, and v2 is equal to y2 minus y1. So we're going to take our x values here. We've got -5 minus -3 in the first, and then 2 minus 4 in the y spot over here. And that's going to give us -2, -2. So that's the component form of our vector. Our vector itself is -2, -2. So now we just want to know the magnitude. So we put our vector v down here with the lines, and we simply take the square root of these added together when they're squared. So square root of -2 squared plus -2 squared, that's going to give us the square root of 8. If you want, you can simplify that to 2 times the square root of 2.